Hello to all. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss energy released by protein, fat and carbohydrate. We know that in our body we require energy. How much energy we require, we should know first. Daily we are eating. How much energy we require per day? Then average energy required for men, that is 2300 kilocalorie per day for men, and for women it is required 1900 kilocalorie per day. For men it is more. For men 2300 kilocalorie means 2300 kilocalorie, but for women it is less, 1900 kilocalorie per day. A normal variation of plus minus 20% is accepted for younger adults. The requirement of persons beyond age 75 are likely to be somewhat less as a result of reduced body size and activities. The average adult needs about, actually in kilojoule also you can understand. Generally in kilocalorie, energy is generally represented in kilocalorie, but in kilojoule also can be converted. Then for average adult in kilojoule I am talking about, that is about 8700 kilojoule per day, 8700 kilojoule. Okay, you can tell the energy in both form, in term of calories also, in term of joule also. Then here I want to tell you relation. Both are related. One calorie means 4.2 joule. This is the relation. 1 calorie, that is equal to 4.18, exact way. We can write 4.2 joule. This is the relation. Okay, that is roughly 4 times. Calorie means more energy and joule means less. If calorie you are knowing, you can know in joule also, just simply by multiplying by 4.2 or roughly 4. Correct? If you want exact, then 4.18. 1 calorie is equal to 4.18 joule. This is the relation. Then these energy I told you for men 2300 kilocalorie per day, and for women 1900 kilocalorie per day is required. Then how we are getting this energy? That is very, very important questions. We eat, but all will not know that how they are getting this energy. Then now I am telling you that we are getting energy through 3 things. First thing is carbohydrate, second is fat, and third is protein. These are the main sources of our body energy. These are the main sources of our energy: protein, fat and carbohydrate. Correct? Then now how much protein will give energy, how much fat will give energy, how much carbohydrate will give energy. That actually I am going to discuss, and how you are getting the energy. Food you are eating, after that what is happening, that just little things I will tell. Then actually what happens that in food we are eating different type of foods we are eating, correct? Sometime, but main food main food you can say, that is carbohydrate. Generally we will eat more, correct? We are eating vegetables also, milk also, many things we are eating. Then in all food you will get that is all these three you will get: protein, fat, carbohydrate, vitamins. Vitamins will not provide you energy. It is very less. Their role is different. Okay, vitamin you need daily. Some vitamins will form in the body, and some you have to take from the outside. Then generally from the food you will get protein, fat and carbohydrate. Okay, in all food you will get it, but quantity may be less. In some it may be more, correct? But generally common food you will get all the three. But here how will you get all energy, that I am telling you. Then just by giving us one example I will explain all the things. Actually this in our food carbohydrate is found more. Then this carbohydrate, what are the example of carbohydrate? Then carbohydrate examples, just for actually it is a very large number, which number is more, but what is the common, that I am telling you. Many carbohydrates are there. Okay, all are carbohydrate, they have different name. Then common way, in a common way carbohydrate we are taking in the form of sucrose, fructose, glucose, maltose. These are common carbohydrate. Okay, main is sucrose. Sucrose also you can tell, that is the starch. Starch actually that is bigger unit that breaks into different type of smaller molecules. All are called carbohydrate, only names are different. Then main is starch in the form of rice or wheat or any other grains what we are eating, these are present. Then that will provide you the sucrose, glucose, fructose, maltose. All things is provided by carbohydrate. All are carbohydrate only. After taking food, what will happen, that this carbohydrate, as for example I am telling you glucose. Glucose is the smallest unit of starch. Whatever you are eating food, finally it will convert to starch. It will convert to glucose. Starch is the bigger unit, very big unit, that will actually after hydrolysis it will give many other smaller units of carbohydrate, correct? And finally that is the smallest unit, that is the glucose, correct? And sucrose is bigger. Then here glucose and fructose both have same type of structure, okay? Then actually both are isomer. Chemical formula is same. chemical formula and molecular mass both are same, both are isomer. Then here, just by giving one example how you are getting energy from the glucose, because from the starch you will get finally glucose, and this glucose actually on combustion, actually it will burn in presence of oxygen. We are taking oxygen, then some oxygen is used here. Glucose in the presence of oxygen, it will burn. That is called combustion. And after combustion, it will give 3 products. First product, that is the carbon dioxide gas. And second product, that is the water. And what is the third product? Third product, what we are talking here, that is the energy. Energy, it will release energy. Means glucose in presence of oxygen, it converts to, or it gives to carbon dioxide gas. That gas we are releasing from our nose. Plus it will also form water vapor. And third things, that is the energy. It will give energy. Then 1 mole of glucose, it gives 2803 kilojoule energy. Is the unit. Joule is the unit of energy. Then 2803 kilojoule per mole. From the 1 mole, you will get this amount of energy, 2803 kilojoule. Here I want to tell you, mole and molecule is different. Molecule means very small. Okay, mole means bigger unit. Okay, that is the Avogadro number. That is the number 6.02 into 10 to the power 23 particles or molecules or atoms or ions, that is equal to 1 mole. Okay, and 1 mole, easy way here you can understand that it is a molecular mass, that is equal to 1 mole. Then here in case of glucose, its molecular mass is 180. We are telling that we are getting energy 2803 kilojoule per mole of glucose, means 180 gram. Here all mole is not the same mass. It will differ. It will vary from substance to substance. Correct? As for example, for fructose different, for sucrose different, for glucose different, for maltose different. Correct? Then here in case of glucose, 180 gram, 1 mole means 180 gram gives 2803 kilojoule. Correct? 180 gram. Then this way, actually for whatever we are eating, all is going to be reacted. It will react. Then on the basis of the reaction, chemical reaction, we are calculating the energy. Then here, just considering the reaction, we are calculating the energy. And here, just few example I want to give you. Fructose and glucose both have same type of mass. Molecular mass is same, 180, exact way 180.16 gram per mole. Then 1 mole of fructose and 1 mole of glucose both will give roughly same energy. Means what I told you, 2803 kilojoule per mole. Okay, and exact is 2812, 2812, that is the exact kilojoule per mole. That is given by 1 mole of either glucose or fructose. Now sucrose. Sucrose, what is actually sucrose? Sucrose is common, what we are using in house daily, in milk and tea you are mixing, that is actually called sucrose. And its molecular mass, molecular formula is C12H22O11, and its molecular mass is very high, 342. Means now here 342 gram means 1 mole. In case of glucose 180 gram means 1 mole. Here 342 gram means 1 mole. Glucose formula was, I didn't tell you, that is C6H12O6, and this C6H12O6, when it will react with oxygen, that is the balanced equation is there, 6O2. 1 mole of glucose reacts with 6 mole of oxygen. For 1 mole glucose you require 6 mole of oxygen, and then it will give 6 mole of carbon dioxide and 6 mole of water vapor, correct? And third product I told you, energy, 2803 kilojoule energy. Then like that way, fructose also reacts in the same way. Sucrose also reacts. It requires more you can say oxygen. Sucrose also reacts with oxygen, same way, but now product will be different. Here also you will get carbon dioxide and water vapor. Then here you will get energy, more energy you will get. Here you will get 5640 kilojoule per mole. See, now from the glucose you were getting 2803. Now here you are getting 5640 kilojoule. Roughly how much you can say? Here 28 and here it is just double, you can tell. Not exact double, but it is a double. 28, here is a 5640. That was 2803. That tells about that here 2 glucose molecules are present here in sucrose. That's why your result is coming, value is coming roughly double. But from the 1 mole of sucrose you are getting 5640 kilojoule, roughly double of glucose by 1 mole. Here 1 mole means 342 gram. 342 gram sugar, common sugar. If you will eat 342 gram, then you will get 5640 kilojoule per mole. And here, if you want to tell in term of calories, then divide it by 4, roughly 4. 4.18 I told you, just to get idea in calories, then it will come 1350 kilocalorie per mole. Kilo means 1000, correct? 1000. Just to multiply by, divide by 1000, then if calories are there, calories means small. You divide by 1000, it will convert to kilocalorie, correct? Just like 1000 gram, that is 1 kg, same way. Then 1350 kilocalorie per mole you are getting from 1 mole of sucrose, sugar, common sugar, correct? Now this I have told you that how much energy you are getting from the carbohydrate, correct? Then example of carbohydrate I told you, that is glucose, fructose, sucrose. Same way maltose is there, okay? That is also carbohydrate. Now I want to tell you about these things, fat and protein. Actually this fat and protein also we are eating, along with our food, correct? And in rice also it is present, in wheat also it is present, quantity may be less. In vegetables, we are eating vegetables, fruits, then in all the things we get all carbohydrate, fat, protein, vitamins, many things you will get. That, but energy you will get only by, mainly by these things: carbohydrate, fat and protein. Then now here just I want to tell you about the protein. Actually, in all the protein, nitrogen is common, carbon will be there, hydrogen will be there, oxygen will be there, nitrogen will be there, sulfur will be there. Okay, sometimes phosphorus will be also there. Then here, that in protein, actually in carbohydrate you will get only three things: carbon, nitrogen, oxygen. In fat also you will get only these three things: carbon, nitrogen, oxygen. But protein, in that you will require extra carbon, hydrogen, oxygen will be there, but nitrogen will be also there, sulfur will be there, phosphorus will be there. Okay. Sometimes you can find halogen also, fluoride, chloride, bromide, iodide. All things are possible. Then here, that in protein, how much energy you will get, that actually protein is of different type. Then here per gram I am telling you, different type of proteins are there. Then here per gram you will get, if you will take protein per gram, actually that will also give you energy. Then just I am telling you, from the protein, per gram protein, it will give you 17 kilojoule. 17 kilojoule per gram, or it divide by 4, then you will come to know by calorie. Correct? Calorie is bigger unit than a joule. Then 17 kilojoule, then divide by 4.18 means 4.2, or 4 also, then you will get idea. Then per gram it provides 4 kilocalorie per joule. 4 kilocalorie per gram. Okay. In term of joule, 17 kilojoule per gram. But in term of calories, you will get 4 kilocalorie per gram. Okay. From the protein. From the protein, 17 kilojoule, or also you can tell 4 kilocalorie per gram. Now, here I want to tell you, protein in our body, gas forms. It is common. Formation of gas is common because we eat many things. Then after the reaction, they will give different type of products. Sometimes product may be solid, sometimes products may be liquid, sometimes products may be gas. Then here in protein, I told you sulfur may be present, nitrogen may be present. What type of protein you are taking accordingly. Then nitrogen is present, sulfur is present, phosphorus is present, chloride, fluoride, bromide, iodide, all things are possible. Then generally phosphorus, sulfur and nitrogen, they will form different type of gases. Okay, it gives different type of product. Then here, gas, for the gas formation, protein has a major role. Okay, and here you can say with from the carbohydrate, only one gas is forming, that is a carbon dioxide, that is coming from our nose. Then I told you about the protein, how actually gas is formed. Actually for the gas formation, other things are also responsible. In cooking time we are using many things, correct? Then this that is also responsible for the gas formation. Okay. Now this I am coming for the fat. How much fat will give you energy? People will think fat will create problem, fat creates problem, but it is not like that. It actually sometimes it helps. When you are sick, that time fat plays a big role, because that time you will not eat. Then fat present in our body, that gives energy, and it gives more energy than protein. Correct? 37 kilojoule per gram, or divided by 4 you can do, then 9 kilocalorie per gram. 1 gram fat gives 9 kilocalorie, or in kilojoule just multiply by 4, roughly we will get 37 kilojoule per gram. Correct? Fat also gives energy. Protein also gives energy, not only carbohydrate. And carbohydrate, I told you already that per gram, if you compare by per gram, then carbohydrate also gives 17 kilojoule, just like protein, 17 kilojoule per gram. Okay. Then here I told you about I've given you these things, some data that related to energy, that how much protein will give energy, how much fat will give energy, how much carbohydrate will give energy. And energy, I told you that you can convert, if you are knowing calories, you can convert in kilojoule. Simply kilo means 1000 you have multiplied. Okay, kilo just like 1000 gram, that is 1 kg, like that way. K, that is called K. Then you can know in the term of K also, and without K also, in the joule also, calories also. The joule and calories are related. I told you 1 calorie is equal to 4.18 joule, roughly 4.2. Correct? And if you want to tell in the kilojoule, just only you write K. K means 1000 you have to multiply. That you divide. If joule is there, divide by 1000. You will get in answer, you will get in kilojoule. Then I have discussed about you can say energy from protein, fat and carbohydrate. Now I am stopping only here. Thank you.